So with this video, we pick up where we left off in our discussion in class today with regards to inequalities. We talked about how to graph an inequality, and for our purposes, we're going to keep those graphs fairly straightforward. But now we need to move on to actually solving the inequality so that once we have a solution, we can then move on to the graphing. Now, don't forget, when we solve, it's understood to mean not only the solution, but the graphed representation of that solution as well. And the other thing that we should also keep in mind is that with an inequality, it technically, when you have a solution, it technically represents an infinite number of solutions. But we want to consider that there are some boundaries with regards to where those solutions exist. So that is one of the reasons for why we have a number line to give us a visual representation of our solutions, so that we can see that there's some established boundary by way of a point, a filled in dot or an open dot, and a graph that extends as a ray to the right or to the left to represent those infinite number of values that could make our inequality true. So now that we're getting ready to solve inequalities, the process itself should be pretty familiar to us. Everything that we learned with solving equations is going to be put to use with solving inequalities. So it's going to be really helpful to dig into our bag of tricks or into our toolbox to make use of what we know with regards to solving equations. And most specifically, when it comes to solving one-step equations, we know that we can use inverse operations. And for today, we're only going to be using addition or subtraction. So don't forget, if we have addition already, then the inverse of that is naturally subtraction. And if we have subtraction, then the inverse of that is naturally addition. They're just operations that undo each other. So we know that already, and we've done that with solving equations. Another quick thing for review is with regards to when we get around to graphing our solutions. When we have the inequalities that are less than or equal to, with the equal to bar underneath, or greater than or equal to, we will use a closed dot, like so. And when we're graphing inequalities that are less than or greater than, we'll use an open dot. And remember, that's just a circle that goes above our value on our number line, as we learned today when we were doing graphing in class. Okay? So from there, once we establish our point, either our exact value or as close to that value as possible with an open or closed dot, then we just draw our ray, or I should say not draw a line, draw a ray, moving left or right to represent all our possible solutions. So let's get moving. So we've seen equations that look very familiar to this first problem. X minus 14 is equal to -6. We would have naturally added 14 to both sides to solve for that equation. Well, that's going to be no different for when we solve our inequality. Well, to undo the subtraction, we will add 14 to both sides. Now, if you need to, if you don't have the use of a calculator, remember you have rules for adding combinations of positives and negatives. You also have the scoreboard. So, but we should be getting comfortable at this stage in the year of knowing that -6 plus 14 gives us 8. And we're not dealing with an equation, so we're going to carry that inequality symbol down. So x minus 14 is greater than -6. When we add 14 to both sides, it gives us a solution of x is greater than 8. Now again, that's only half of our final answer. The other part of our answer is we draw a very simple number line. We mark 0 on our number line as a point of reference. And then from there, we mark the value that shows up in our solution, 8. And the reason why I like to have 0 on my number line is it's a point of reference so that I know 8 being positive goes to the right. And now I mark my dot, and because it's greater than without the equal to bar, I will put an open dot, and then I will draw my ray to the right. All of this represents our complete and final answer for the solution of x minus 14 is greater than 6. Now, if we move on to the next problem, another inequality. Again, we see subtraction in the problem, so we want to undo that subtraction with its inverse addition. So we'll naturally get rid of the minus 3 by adding 3 to both sides. 24 plus 3 is 27, is greater than or equal to y. Now this problem I don't like. For the same reasons for when we were solving equations, we never liked to see the variable on the right-hand side in our answer. We also don't want to see the variable on the right-hand side in our answer for inequality. So what we have to actually do here is to do basically a 180-degree turn of this answer. So by the time we're done, we want this to read from the variable first. Y is less than or equal to 27. Now there's some benefits to that in the sense that as we graph more and more, when we lead with the variable, we'll begin to recognize that the direction that our inequality symbol points is going to tell us the direction that our graph has to go. So let me say that again. The direction that our inequality symbol points, when we state our answer in the proper order, makes it clear to us that after I put my closed dot in this case, it makes it clear to us that our graph is going to point to the left because my inequality symbol points to the left. So the main reason, or not the main reason, but the primary benefit for us to lead with our variable with inequalities is it's always going to point us in the direction with the inequality symbol that our graph is going to need to go. So I think it's important that we probably mark this problem with a star because of the fact that we had to reverse our final answer. Okay? So the last problem should be quick and painless. Because we're adding 3 in the original inequality, we'll subtract 3. We know 3 minus 3 cancels. We know we have x. We're in the right order because x is leading the way. It's to the left of our solution, is less than or equal to. Negative 8 minus 3, careful, we're subtracting from a negative. That gives us negative 11. Draw our simple number line. We should be getting the hang of this. 0. Negative 11 being a negative number will go to the left of 0. A closed dot. And again, our inequality symbol will quickly point the way to the left. All our values to the left of negative 11 included, will be the graphed solution. Okay, so those are your notes for today. There's a Google form that will go along with this, so please log on and complete the Google form, and we'll get more practice done in class tomorrow.